Let's jump right into this explainer. Today, we're going to completely change how you look at that big metal box sitting outside your house. I really want you to stop thinking about your HVAC unit as just some regular appliance. Instead, see it for what it truly is, a hardworking, complex piece of machinery that is literally in a 24/7 battle against the harsh elements. And to really understand this battle, we're going to use Middle Tennessee, specifically the Lebanon area, as our ultimate stress test case study. The wild temperature swings and heavy humidity out there, they basically create the perfect storm to push a heating and cooling system right to its absolute breaking point.
So here's our roadmap for today. We'll start off by looking at the Middle Tennessee climate. Then we'll learn how to decode common system failures, dive into the actual economics of HVAC, and finally, we'll cover the professional service standards you absolutely need to demand. By the end of this, you'll know exactly how to spot problems and use some specific financial formulas to make sure you're not getting ripped off on repairs. Okay, let's dive right into Section 1, the Middle Tennessee climate, which is basically the ultimate HVAC antagonist. To really understand how machines break down, we first have to look at the environment that's actively trying to break them. We're talking about a humid subtropical zone where summers can easily hit 90 degrees with just crushing moisture, and then winters drop below freezing. But what's incredibly fascinating here is how localized these environmental threats actually are. We're talking about microclimates. Like the red clay soil around Lebanon, it literally shifts with seasonal moisture, which pulls on and damages outdoor units and those delicate refrigerant lines. Move down to the Cedar Forest and Hartman Park areas, and agricultural dust becomes the main villain, clogging up filters way faster than normal. And hey, if you're near the Cumberland River Valley, that morning fog and sudden evening temperature drop, it forces your system to constantly switch gears and just overwork itself. The environment is relentlessly wearing down the machinery. But the antagonist isn't always just the weather outside. Sometimes it's actually built right into the house itself. You see, a lot of homes built in the 1980s and 90s feature older ductwork that has just degraded over time. So what does this mean for you? Well, it means that even if you drop 10 grand on a brand new state-of-the-art system, it's still going to struggle to keep your home comfortable. Why? Because your home's ductwork is literally throwing your conditioned air away, just dumping it right into attics and crawl spaces. You're basically paying to air condition the great outdoors. Moving right along to Section 2, recognizing common system failures. It's time to translate those symptoms when your system is basically crying out for help against the climate. So let me ask you a question. Why is your furnace short cycling? You know the sound. That's when your system rapidly turns on, runs for maybe a minute or two, and then shuts right back off over and over again. Not only is it incredibly annoying to listen to, but short cycling is actually one of the absolute fastest ways to waste energy and totally destroy your internal components. Now, the culprits behind this range from super simple fixes to some pretty major design flaws. The most common one, a dirty filter restricting your airflow. It causes the system to overheat and triggers a safety shutoff. It could also be a failed limit switch, maybe a malfunctioning thermostat, or, like we mentioned, leaky ductwork dumping heat into the attic and throwing off the temperature readings. But another massive issue is oversized equipment. If your system is too big for your house, it heats or cools the space way too fast and then just shuts off abruptly. So yeah, bigger is definitely not always better in the HVAC world. And you can actually diagnose some incredibly specific problems just by listening to it. If you're hearing grinding or squealing coming from your unit, you're almost certainly dealing with mechanical friction. That's usually bad bearings in the blower motor, or worse, a compressor crying out right before it completely fails. On the flip side, if you're hearing popping and banging, it's typically an airflow and pressure issue. That's the actual sound of metal ductwork physically expanding and contracting, or loose parts vibrating against the cabinet walls. Then, of course, there's the classic summer nightmare. Your AC starts blowing warm air. When this happens, it's rarely a big mystery. Think about it. Air conditioning is really just the science of moving heat from inside your house to outside. So if it's blowing warm, your system has simply lost its ability to transfer that heat. And that almost always comes down to one of two things: either low refrigerant escaping from a leak, or dirty coils acting like a thick blanket and physically blocking the heat transfer from happening. All right, let's get into the most crucial part of this explainer in Section 3, the economics of HVAC. These are the absolute dollars and cents rules of thumb you need to keep your home comfortable. $5,000. I really want you to burn this number into your memory. This is the golden rule that's going to save you from throwing good money after bad the next time a technician hands you a massive repair bill. Let's just walk right through the math on this one. It's a super simple formula to definitively decide whether you should repair your broken unit or just replace the whole thing. Here's what you do. Take the age of your system in years and multiply it by the cost of the quoted repair. If that total exceeds $5,000, well, it's time to replace it. To put that into perspective, say you have a 12-year-old system facing a $500 repair. 12 times 500 is 6,000. That firmly exceeds our threshold, sending a very clear signal that repairing it is a bad investment because another major component is probably going to fail soon anyway. Now, if you do have to replace it, the costs are heavily tied to the actual size of your home. Your square footage essentially dictates the tonnage, which is just industry speak for cooling capacity, that you're going to need. A standard 2,000 square foot home usually requires 3 to 3.5 ton system, which will run you roughly $6,000 to $10,000 to install. But if you double that square footage to 4,000, you'll need 5 to 6 tons of capacity, maybe even split across 2 separate units. That pushes the price tag up to somewhere between $12,000 and $22,000. It's completely tied to the raw physics of moving air through your specific space. Okay, here is a completely free, dead simple hack that can literally save you thousands of dollars. The 3-minute rule. If your AC shuts off, whether you turned it off manually or maybe the power just flickered, you absolutely must wait at least 3 minutes before turning it back on. Why? Because the refrigerant inside is highly pressurized, and waiting gives that pressure time to equalize. If you just immediately restart it, you're forcing the compressor to push against a massive wall of high pressure, which risks a catastrophic mechanical failure. And trust me, the compressor is the single most expensive part of your entire system. So the crucial takeaway here is that how you treat this machine totally dictates how long it's going to serve you. If you just let your system run constantly in that harsh climate without ever servicing it, it's going to burn out in about 10 to 12 years. But if you invest in some simple, routine annual maintenance, that lifespan suddenly jumps to 15 to 20 years. Think about that. You are literally buying yourself up to a decade of extra life just by keeping the coils clean and the parts tuned up. It's a no-brainer. And if you want to maximize your financial investment even further, timing is everything. First off, try to buy your new system in the shoulder seasons, so fall or spring. If you wait until your AC dies in the dead of July, you're absolutely going to pay emergency peak season pricing. Second, look into the Inflation Reduction Act. The federal government is actually offering a tax credit of up to 30%, which is capped at $2,000, for installing qualifying high-efficiency heat pumps or AC units. And lastly, do not rely on your homeowner's insurance to bail you out. They cover sudden perils like storm damage or lightning strikes, but they will actively deny your claim if it's based on normal wear and tear or deferred maintenance. All right, let's move into our final section. Section 4, Professional Service Standards. Because all of this knowledge is useless if the job isn't getting done right. Because here's the thing. Knowing the $5,000 rule or the 3-minute rule doesn't help you much if the technicians doing the actual work are just cutting corners and ignoring industry science. Professional outfits like Alpha HVAC over in Nashville and Lebanon use a very specific, straightforward 3-step workflow to remove any uncertainty and really protect you, the consumer. Step 1 starts with immediate dispatch using trucks that are actually loaded with parts, so you aren't sitting around waiting days for a simple capacitor. Step 2 is diagnosis and approval. They measure the actual performance, explain failure to you in plain English, and give you an upfront price before they even lift a single tool. No hidden fees. And finally, Step 3. Repair and verification. They don't just swap out the part and bolt. They stick around to test the entire operation to make sure it matches the manufacturer's specs and confirm all your warranties. Look, HVAC is not guesswork. It is literally applied physics. A true professional follows strict industry codes. For instance, they must hold an EPA Section 608 certification to even legally handle refrigerants. And they definitely shouldn't be just eyeballing or guessing the size of the unit you need. They should be running an ACCA Manual J load calculation to figure out your exact heating and cooling needs based on your home's windows and insulation. They use Manual D for ductwork design to ensure the airflow is perfectly balanced. And they use digital manifold gauges to run superheat and subcooling checks. If your tech isn't using these exact standards, honestly, they're just guessing with your money. So the crucial point here is why precise sizing matters so incredibly much for controlling that massive summer humidity. If a contractor just slaps a huge oversized unit into your home thinking, hey, bigger is better, that system is going to cool the air so fast that it shuts off before it even has a chance to pull the humidity out of the room. It short cycles and your home is left feeling cold, but really clammy and damp. On the other hand, if they undersize it, the machine just runs 24/7, driving up your electric bill like crazy, and you're still sitting there sweating in August. Precision really is everything. Which leaves us with this final, really important question to consider. Is your HVAC system actually ready for the next massive seasonal shift? Or have you been ignoring the warning signs? We've seen just how brutal the elements can be, how a little simple maintenance buys you a whole extra decade of lifespan, and how demanding the right professional standards protects your wallet. Do not wait for the next major heat wave to test your machinery. Take action now, go check your filters, do the math on the $5,000 rule, and give your HVAC the respect it truly deserves. Thanks so much for joining me on this explainer, and I'll see you next time.